In this video, we're going to take a look at section 4.5, which is on factoring expressions of the form ax squared plus bx plus c. To factor trinomials of the form ax squared plus bx plus c, we have two options that we could employ. The AC method, which has a set of steps that you follow to get to the result, or you can do trial and error, or guess and check, whichever you want to call it, to try to figure out the answer. So I may, on one example, show you how trial and error works, but for the most part, I'm going to stick with the AC method because it's a step-by-step process. So I think it's just easier to follow, easier to teach. With practice, you can get pretty good at using trial and error, and I would encourage you to look into it. But on the video, we'll stick with the AC method. The AC method works in the following way. Step 1, find A times C. Step 2, find two numbers that multiply to AC but add to B. That should sound familiar because we did something very similar in the previous section, section 4.4, when we were factoring where A was equal to 1. We had a step in that process that was very similar to that. Step 3, this is going to be different. Rewrite the middle term using the two numbers from step 2. And by doing that, you're going to create four terms in your expression. And so now that we have four terms that are set up in a very particular way, we will use factor by grouping to finish out the factoring process. Because we chose these two numbers carefully for the middle term, factor by grouping should work out perfectly fine. If we pick two random numbers to use for our middle term, chances are factor by grouping isn't going to work. So they have to be chosen very carefully, and that's what this process helps you to do. All right, so let's take a look at an example. All right, we have 3w squared plus 14w plus 8. So let's talk about using the AC method on this particular problem. The first step is to find A times C. So A times C in this problem, A is equal to 3, C is equal to 8. So A times C will be 3 times 8, which is 24. Step 2, we want to find two numbers that multiply to AC, but add to give me B, which in this case is 14. Right, B is equal to 14 for this particular problem. So two numbers that multiply to 24, add to 14. Again, you might have to make a list to help you figure it out. This one's not too bad. The number's pretty small. Could be 1 times 24, 2 times 12, 3 times 8, or 4 times 6. These are all the numbers that multiply to 24. And we see the second one on our list adds to 14. So those are the two numbers we're looking for, 12 and 2, or 2 and 12. The order you put those in doesn't really matter. Step 3, unfortunately, you don't get to just jump to the answer. So when we were doing this in 4.4, we found these two numbers, we jump right to the answer. We were able to factor it immediately. That doesn't happen in this section, and the difference is because A is not equal to 1. Right? A is equal to 3 in this particular problem, and so we can't use that shortcut. We have to do it the long way, which is to rewrite this middle term using these two numbers that we just found in step 2. So I'm going to rewrite 14w as 2w plus 12w. It's the same thing, right? 2w and 12w combined together to give me 14w, just writing it in a different way. The first term gets copied down, 3w squared, and the last term gets copied down, the plus 8. And so this was step 3, splitting up the middle term using those two numbers that we just found. And then step 4 is to use factor by grouping to finish this out. So we're going to group the first two terms together. We did factor by grouping back in section 4.3. So if you need to go back and review that, I would recommend doing that because we're going to use the same process in 4.5 for a lot of these problems. All right, group the second two terms together. Always start with a plus sign between your two groups. The common factor in the first group is just a w. We'll have 3w plus 2 left over. And the common factor in the second group would be a 4. And when we factor that out, we'll also have a 3w plus 2, which is critical because these have to come out the same for this to work. So if we didn't choose 2 and 12, if we picked two other numbers like 10 and 4, right? 10 plus 4 also is 14. But if we had 4w plus 10w here, we would not get these parentheses to match up, and therefore factor by grouping would not actually work. So it's very important that you get these two numbers exactly right in order for this process to work out. So we will factor out the 3w plus 2, write it one time out in front, and then in a new set of parentheses, we will write what's left over, which is the 4 and the w. I'm sorry, I'm saying it backwards. The w plus the 4. So we have w plus 4. And now this is factored because now we have two things being multiplied together. All right, so that's how the AC method works. Let's take a look at another example, and maybe I'll, with this example, show you how trial and error works. First thing we want to do with this one is rearrange it so that it's in order from highest to lowest power. So we have 8v squared minus 20v minus 48. And for every factoring problem that you do in Chapter 4, the first thing you want to look for is a common factor. I failed to mention this in our last example because I mentally make that check, but I don't think to say something about it if it doesn't have any, if there's nothing happening with it, right? So, sorry, no, that didn't really sound right, but so when I look at this expression, I immediately notice there's no common factor, and so I don't think to mention it. But I do check, is there a common factor here that I could factor out? And there isn't one, so I just move on to the AC method. But for this one, I notice there is a common factor, and so that's when I remember, oh, I need to say something about that. So the common factor here is going to be 4. So again, they're all even, so you know at least a 2 could be factored out, but you want to look for something bigger. You want to get the biggest number factored out that you can, and it looks like 4 will work with all of these. So we're going to factor out a 4. We'll be left with 2v squared minus 5v minus 12. All right. Then we will try to factor what remains in the parentheses, and we could do the AC method. It wouldn't be too terribly difficult to do here. It's going to be 24 again, in fact. But I would like to do a problem by trial and error, so I'm going to choose to do this one by trial and error. Hopefully that's going to be okay. All right, so trial and error works like this. We are going to assume that this can be factored, and that when it gets factored, the answer is going to look something like this. We'll have two parentheses where there's 2 terms in the first parentheses, 2 terms in the second parentheses. To get the 2v squared, that will come from the f in the FOIL process. So whatever I have for my first 2 terms, they have to multiply together to give me 2v squared. Right. And really there's only one way for that to happen. For one of the terms to be 2v, and for the other term to be just v. 2v times v is going to give me the 2v squared. All right. To get the last term in our trinomial, that will have to come from the L in the FOIL process, multiplying the last 2 terms together. Now here's where things get a little bit tricky. There's a few ways that can happen. We could have 12 times 1. We could have 6 times 2. We could have 4 times 3. Those are all different ways that we could get 12. However, none of these are going to work because that would produce a common factor here of 2, right? We'd have 2v and 12, 2v or 6, 2v or 4. Any of those is going to give me a common factor of 2, which I would then have to factor out. But if the problem I'm working on doesn't have a common factor of 2, my answer should not have a common factor of 2. So I can immediately rule these out as possibilities because they would all have a common factor of 2 that just doesn't exist. The other possibility is the same numbers but the other way around. So you could have 1 over here and 12 over here. That doesn't have a common factor that we have to worry about. You could have the 2 over here and the 6 over here. That one can't work because, again, 2v and 2 has a common factor of 2. So that one can't work. Or you could have the 3 over here and the 4 over here. Right? So really, these can't work because of that common factor of 2. So I'm really down to just 2 different guesses that I have to check on. So these are all the different guesses that we could make for how this factors. A lot of them are being eliminated because of that common factor of 2, but there's a couple left over that we have to check. And the way you check them is by taking your guess and foiling it out to see if it matches up to the problem. So let's go ahead and try the first one we have here. We have 2v minus 1, and then we have v and 12. And I don't know why I put minus 1 there first. We need it to multiply to negative 12. So one of them does need to be negative. So I could choose for the negative 1, or for the 1 to be negative. But then the 12 would have to be positive. So negative 1 times 12 gives me the negative 12. Another possibility is it could be 2v plus 1, and then v minus 12. And you'll just have to kind of check either one to see which one gives you the negative 5v in the middle. We don't really have to check the other parts of this problem because the way this guess is set up, I know I'm going to get 2v squared from the f in the FOIL process. I know I'm going to get minus 12 from the L. The only thing I don't know about is that middle term. Which guess is going to give me the negative 5v in the middle? So I'm going to see if it's this one. So we'll check by doing FOIL. So first outer, inner last. And so we'll do 2v times v, which is 2v squared. 2v times 12, which is going to be 24v. Negative 1 times v, which will be negative v. And negative 1 times 12, which will be negative 12. When I combine those together, I get 2v squared plus 23, not 23. I said 23, but I wrote 32. I don't know what's wrong with me. All right. Plus 23v minus 12, which doesn't match up to the negative 5v. So this is not what I was looking for, which means this is not the right answer. This is going to work out the same way, except you'll have 2v squared minus 23v minus 12. And so that also does not give you the thing you're looking for. So that is not how it factors either. So let's try our other guess here. We have 2v, let's do minus 3, and then v plus 4. And if this gives me plus 5, then that means this is the right answer, but I have the signs backwards. So let's just see what we get from this. And if that isn't right, we'll check plus 3 and minus 4. So I'll have 2v times v, that'll be 2v squared. No surprise, that's how I designed my guesses, so I would get that. 2v times 4, which is going to give me 8v. Negative 3 times v, which will give me negative 3v. And then negative 3 times 4, which will give me negative 12. Again, no surprise, because that's how I set up my guesses, so that would happen. But this one's going to give me 5v in the middle. Positive 5v, let me say that, which is not what I was looking for. I wanted negative 5v. So what should work, but let's just go ahead and check, is having the 3 be positive and the 4 be negative. So let's FOIL this one last time. We get 2v times v, which is going to be 2v squared. 2v times negative 4, which would be negative 8v. 3 times v, which would be positive 3v. And then 3 times negative 4 is going to be negative 12. When I combine the two terms in the middle, I get negative 5v, which is what I was looking for. And so this is actually how that's going to factor. So my final answer for this problem is going to be, this will factor as 2v plus 3 and v minus 4, I should say times v minus 4. And don't forget we had a common factor that we factored out at the beginning. That should also go in my final answer, and so we'll put that out in front of that. And so this is what I would type into Math Excel. All right, so that's how trial and error works. It's a little bit messy. That's kind of why I don't like it, because you just make different guesses and check them, and you have scratch paper where you're doing all these checks until you find the guess that gives you the right term for the middle of your trinomial. All of your guesses should automatically give you the right first and last term. So you're just really checking to see which one gives you the right middle term. And sometimes you'll get it right the first time. You know, I kind of had a feeling that 1 and 12 wasn't going to work, but I kind of wanted to give you a good sense of the experience of using trial and error, because you're going to make some guesses that don't work. You check it, it ends up not working out. So you have to abandon that one and then you check a different one. And you might have to do that several times before you finally stumble on the one that gives you the term that you're looking for in the middle. Other times you might get it right the very first time. And so it's kind of alluring in that way, because it might be just a little bit of work if you get lucky and get it right the first time, or it might be a lot of work if you have to end up doing like 5 or 6 guesses. So the more you practice it, the better you get at it. So I'm not going to discourage you from using trial and error, but for the rest of this video, I'm just going to stick with the AC method because I like that step-by-step process, which works really good for this format. So, all right. take a look at another example. Now I say that I'm happy with the AC method, but this is actually one of the worst case scenarios for the AC method because of how big these numbers get. So the first thing I want to do, just like on any factoring problem, and I think to mention it here because I can see I need to do it, is factor out a common factor, right? Each of these has a factor of b, so let's factor out that common factor first, and we'll have 20b squared minus 39b plus 18 left over. And this we'll do by the AC method. So step 1, find a times c, which is going to be 20 times 18, which is going to be, 360. So it's a pretty big number. Step 2, we want to find two numbers that multiply to 360, but add to negative 39. So to find two numbers that do this, some people are pretty good at this and they can kind of figure it out off the top of their head. I'm not seeing it right now. So I'm thinking of these two numbers, and I've done this problem a couple times in the past, but not recently. And so it's not coming to me off the top of my head. So what I will need to do, there's a couple things you can do. I'm going to show you a couple tricks here. One is the trick I've already shown you, which is make a list of pairs of numbers that multiply to 360 until you find one that adds up to 39. And so we would start like this, 1 times 360. I like to start from the very beginning, so I'm very thorough and I've checked every possibility. 2 times 180, that gives me 360. 3 times 120 gives me 360. 4 times 90, and again, I'm not even close to 39 yet, right? 4 plus 90 is 94. We're not even close to it, but we're getting closer. 5 works, right? Because 5 can divide into 360, and it'll go 72 times. 6 works, so 6 times 60 would give me 360. So a lot of factors for 360. 7, however, does not work, but 8 does. 8 times 40, see what will be left over for 45. If I add those together, I get 53, so I'm not quite at 39 yet. 10 doesn't, or sorry, 9 does work actually. I was going to skip 9, but it does work. 9 times 40, which adds up to 49, getting closer. 10 times 36, that adds up to 46. 12 works. 12 times 30, that adds up to 32. Right, now that adds up to 42. I don't know what I was thinking. I was going to say if it's 32, there's a problem because we skipped over 39 there. So, and I'm assuming this is going to work out. 13 doesn't work. I don't think 14 works. 15? So 15, and I believe it's 24, which does add up to negative 30, or it adds up to 39. To get negative 39, we want to make both of these numbers negative. Negative 15 and negative 24 still multiply to positive 360, but when I add these numbers together, it adds up to negative 39. So that's one way you can find those two numbers. Just make a list. I know it's kind of tedious, but the alternative is to sit there and just kind of try to guess in your head what numbers work, and that could take a long time too for something like this. So I might try for like 30 seconds to see if I can think of it off the top of my head, and if I can't, I just resort to this. I just want to get it over with. So the other thing you can do that has worked for me recently, this is kind of a new method I've developed, is go back before you got 360 with the two numbers that you multiplied together, the A and the C, split those up. Like for instance, 20 could be split up as 4 and 5, and 18 could be split up as 6 and 3, and then just rearrange these, regroup them, right? So instead of having 4 and 5 together to give you 20, let's put the 4 with the 6, and that gives me 24, and then I put the 5 with the 3, and that gives me 15, and I could stumble on it that way. So try breaking down the original numbers, A and C, into smaller numbers, and then regrouping them to see what kind of results you get. And sometimes you can find the numbers you're looking for a little bit quicker that way. All right. Now that we finally have our two numbers, we're going to go to step 3, which is to rewrite the middle term using those two numbers. So I'm going to rewrite negative 39b as negative 15b minus 24b. The first and the last term copy down, but what I'm not going to do is I'm not going to copy down the common factor of b. It'll just get in the way of the next step, which is factor by grouping. So I'm going to group the first two terms together. We have 20 b squared minus 15b. Always start with a plus sign between your two groups. That minus sign will stay with the 24 inside the second group. So we get negative 24 plus 18 in our second group. So common factor in the first group would be 5b. That's going to leave me with 4b minus 3. The common factor in the second group is 6, but because I want this to match up to this, I need to change the sign of both of these terms. So that this one becomes positive, just like this one is, and this one becomes negative. And so I will factor out a negative 6 instead of just 6. And that's going to leave me with positive 4b minus 3. And so they match, right? That's the critical piece here, that these have to be the same for this to have worked out. Because they're the same, I can factor them out. So I'm going to factor out the 4b minus 3, write it one time out in front. Sorry, starting to get a little laggy on me here since I've done a lot of writing on this screen. And then what I'm left with is 5b minus 6. And then copy the common factor down to the front of that. And so this is what I will type in the Math Excel. All right. And you can double check to make sure you found the right answer by foiling this back out. It should match back up to this. And then distributing the b gets you back to the original problem that you started with. And that lets you know that you have the right answer. All right. Let's take a look at the next example. So here, what we want to do, we talked about this previously. You want to write this in order from highest to lowest power. So you're going to start with the x squared term. That should go first. It's negative. So I'm going to write negative 12x squared first. Then the plus 83x, because we're going from highest to lowest power. And then the positive 7 will go last. Now for this problem, there is no common factor for me to factor out. However, I find it's more challenging to do the AC method if a is negative. It's just, there's something about a being negative, it just does not work out the way you're used to, and it just makes it easier to make mistakes, at least for me. So even though there's not a common factor for me to factor out, I'm going to get that negative sign out of the way. So I'm going to factor out the negative. Think of it as negative 1 if you want to put a number with it. And then that will change the sign of all the terms left over in the parentheses. So this will become positive 12x squared. This will become negative 83x, and this will become negative 7. And I find that by having a be positive, that sounded kind of funny, by having a be a positive number, everything's going to go more smoothly from this point on. So AC method, we'll take a times c, which is going to be 12 times negative 7, which is going to be negative 84. B is equal to negative 83. So this time I don't think we'll have to make a list to figure this out. What two numbers multiply to negative 84 but add to negative 83? It's going to be negative 84 times 1. All right, negative 84 times 1 is negative 84. Negative 84 plus 1 would give me the negative 83. So we're going to split up this middle term. Sorry, it's not writing for me. As instead of writing it as negative 83x, we're going to write it as negative 84x plus 1x. All right, so we're just taking the same thing and writing it in a different way so that we can get 4 terms here, right? Because we'll still have the 12 squared and we'll still have the minus 7. But now we can use factor by grouping to try to factor it now that we have 4 terms. So I'll group the first 2 terms together, get 12x squared minus 84x. In the first group, always start with a plus sign. In the second group, I'm just going to write that as x, right? 1x is just x. Sorry, the button on the pen's getting in my way, and I keep erasing what I'm writing. Minus 7. Factor out the common factor in the first group, which is going to be 12x, right? So we'll factor out a 12x. That'll leave me with x minus 7, because 84 divided by 12 gives you 7. Plus, there is no common factor in the second group, but that's okay because we have what we need, which is these 2 parentheses match up. So we can factor out the x minus 7, and I guess I'll have to write it over here. So we write it one time out in front, x minus 7, and then in parentheses we write what's left over, which is 12x plus, and again, there's always something left behind when you're factoring out a common factor. If you take everything away, it leaves a 1 behind. Right? There's an invisible 1 there that we have to write now that the x minus 7 was factored out. And then the last thing is bring that common factor down in front of your answer. And I'm not going to put -1 because Math Excel won't like it. It'll count it as wrong. We're just going to put a negative sign there. All right, let's try that again. All right, my negative sign a little bit more clearly. Okay, there we go. And so this is what I would type into Math Excel, and that should be correct. All right, let's take a look at another example. So I have a couple more. These are a little bit more difficult in the way that they're set up. This one, the difficulty is we have two variables, s and we have w. We talked about this in section 4.4 where we had a shortcut that we actually don't have to employ here. Not really a shortcut, but just a workaround, which is if the two variables fit this pattern, right? The first variable is s. In the first term, we have 2 powers of s. In the middle term, we have 1 power of s. In the last term, we have no powers of s. For the second variable, we have no powers of w, 1 power of w, 2 powers of w. So this is what we talked about in 4.4. Now, the workaround we used in 4.4 was if this is your pattern, you can factor it as if the second variable is not even there. So you just rewrite the problem without the w in the problem, and then you factor it like you normally would, and then you put the w back in at the end. You put it into your answer in the right place, and it just all magically happens to work out. With the AC method, you actually don't have to bother with doing that. So as long as this is the pattern for your two variables, you can factor this using the AC method without having to make any adjustments. You just jump right into the AC method. So that's what I'm going to go ahead and do. So I guess I'll do it down here. So step 1, A times C is going to be 20 times 20. Right? So this is A, this is C. And again, you just grab the number. You don't grab the variable part. Just the number is what A and C are equal to, the coefficient. And so 20 times 20 gives me 400. B is equal to negative 41. Right? And so B is negative 41. So we need two numbers that multiply to 400, but will add to negative 41. All right, so I'm not thinking of what that might be off the top of my head just at the moment. So I'm going to use that second technique I talked about earlier because that's such a big number. I'm going to go back to where these numbers were smaller, split them up. You could do 10 and 2. You could do 5 and 4. I guess that's really the only two ways you can split up 20. I usually try to split them down the middle, at least the first time around. So I'm going to try 4 and 5 for both of them. All right. And to regroup them, there's really only one way you can regroup it, which is to put the 4s together. So let me pick a different color here. I use green. Put the 4s together. 4 times 4 gives me 16. And put the 5s together. 5 times 5 gives me 25. So this will also multiply to 400. Does it add up to 41? Yes, it actually does. Now we want it to add to negative 41, so I'm going to make these both negative. Negative 16 and negative 25. That multiplies to positive 400, but adds to negative 41. So I'm going to rewrite the middle term using those two numbers. So I'm still going to have 20s squared, but in place of the negative 41sw, I'm going to split that up and write it as negative 16 and negative 25. And then we'll have the plus 20w squared at the end. The thing you have to be careful about when you're splitting this middle term up is that you do not split the variables up. The s and the w do not get split up. Just the number 41 is getting split up into negative 16 and negative 25. The variable part has to stay the same on both of them for them to be like terms. So a lot of times I'll get students that put s here and then they put w here. But then you couldn't add these back together to get this middle term again, right? These wouldn't be like terms anymore. So this really doesn't match up to the original problem that you started with. What you need to do is keep the variable parts the same on both of them. This one needs to have SW, and this one also needs to have SW, so that they're like terms, and they could combine back together to give me the negative 41 SW that I started with. All right, so this would be step 3. And then step 4 is to do factor by grouping. Okay, so step 4, factor by grouping. We'll put the first two terms in a set of parentheses. So I'm sorry that s looks like a 5 a little bit. I apologize. So it's 16sw Always start with a plus sign between your two groups, and that negative sign stays with the 25 inside the second group. And then we'll have plus 20w squared at the end of that second group. All right, common factor in the first group would be 4s. I'll take a 4s away from this first term. That leaves me with 5s minus, when I divide the 16 by 4, I'll have a 4 left over. Take away the s, so what I'm left with is the w. For the second group, the common factor there will be 5w, right? They both have a w, so we need to factor the w out. I want this to match up. I want what's left over here in the parentheses to match up with what I have here in parentheses, which means I need the first term to be positive and the second term to be negative. To switch the signs of these, I will have to factor out a negative with that 5w. So that'll leave this as a positive 5s, and this will change to a negative 4w when I divide a 5 out of both of those. All right, I'm sorry, my 5s and my s's, I have that problem on paper, but especially on here, it seems like they're very similar looking, so I apologize for that. So these two match up. So again, I didn't have to ignore the second variable to make this work. The second variable goes exactly where it needs to go. Everything works out just fine, as long as the two variables fit that pattern. I'm going to factor out the 5s minus 4w, and I'll be left with, in parentheses, 4s minus 5w. There was no common factor that I factored out at the beginning, and so this will be my final answer. All right, one more example to look at, and then there's some examples for you guys to try, those of you watching the video. We saw a problem like this in section 4.4, and we actually do have to do this one in a pretty similar fashion. We're going to use substitution, because technically this is not of the form that I need it to be in order to factor it using the AC method, right? The AC method only works on expressions of this form, ax squared plus bx plus c. The highest power here being 2. In my problem, the highest power is 6. So officially, this problem is not something that we can use the AC method on the way it's given to us. However, we notice there are some similarities between the problem I'm given and this formula, which is namely that there's 3 terms, right? They're both trinomials. And so maybe we can make this look like this if we replace the variable with a new variable. And normally I mentioned in 4.4 that we want to use w as our replacement variable, but w is already being used in this problem as the original variable, so we can't use it as our replacement variable. So I'm actually just going to switch to using x. And really the key is to look at the middle term. Instead of w to the third power here, what I really would like to see is just x to the first power. So we're just going to put it there. We're just going to cover up that w to the third power with an x. Replace the w to the third power with an x to the first power. It's like a mask, right? We're just covering it up with, like I said, in class, I literally use a sheet of paper, and I write x on the sheet of paper, and if I had tape, I would tape it over the top of w to the third power. Now the 21 will stay in front of that, and the minus 49 is not going to change from what we're doing here, so I'll just copy that down. And there's a plus here. Now this, I would like to have x squared here, but I can't assume that's automatically going to be okay. This has to be consistent with the choice we're making for the middle term. So I want to make sure that in order to get x squared here, that x is still covering up the same thing, which is a w to the third power. So what I want to do is rewrite this w to the sixth power as something squared and hope that what I get in the parentheses is what x can take the place of, which it ends up being, right? Because w to the sixth power, I can rewrite that as w to the third power squared. So again, I can tape my piece of paper over the top of w to the third power with another x, right? So in both cases, x is covering up the same thing. X is covering up the w to the third power. So by covering this w to the third power up with x, we get x squared as this first term, and then the 4 just gets copied down. And so now we've made our problem look exactly like this formula, which means we can now use the AC method to factor it. So a times c is going to be 4 times negative 49, which is going to be negative 196, I believe. I'm not using a calculator, so I hope that's right. B is equal to 21. So we need two numbers that multiply to negative 196, but will add to 21. Now, because it needs to multiply to a negative 196, one number here will be negative and one will be positive. So when we add these two numbers together, they actually subtract each other. So we really want two numbers that will subtract to give us 21 and multiply to give us negative 196. So again, I'm not really thinking of what that might be off the top of my head, so I'm going to go back to this trick. Now the 4 I could split up as 2 times 2, but what I would like to see first is leaving the 4 as a 4 and just splitting up the 49 as 7 times 7. And then I can take one of those 7s and group it with the 4, and I get 28. 28 and 7 do subtract to give me 21. So I think these are the two numbers we're looking for. We want it to add to positive 21, so I want the 7 to be negative and the 28 to be positive. So those will multiply together to give me negative 196, and those will add together to give me 21. So those are the two numbers I'm looking for. We're going to rewrite the middle term using those two numbers. So I'll rewrite it as negative 7x plus 28x. The first and the last term stay the same, so I just copy those down. And then we do factor by grouping. So this is step 3. Step 4 is factor by grouping. So I'll have 4x squared minus 7x. Always start with a plus sign between your two groups. I know I keep saying that over and over, but I really want to emphasize that's important. Group the second two terms together. Factor out the common factor. For the first group, the only common factor is an x. So we'll have 4x minus 7 left over. The common factor in the second group looks like it'll be a 7. And so we'll have a 4x minus 7 left over from that. Because these two are the same, we can factor that out. So we factor out the 4x minus 7. We write it one time out in front. And then in a new set of parentheses, we write what's left over, which is the x plus 7. And after all that work, you finally get something factored. You're excited to be done with the problem, so you want to just type that into Math Excel and move on to another problem. But don't forget, you want to end with the same variable that the problem started with, right? This problem started with the variable w. We need to end the problem with the variable w. Math Excel is not going to have any idea what x is, right? We introduced that to the problem to make this easier to factor. Math Excel is not going to recognize that as a variable in this problem. So we need to take the x back out. And like I said, if you think of it as a piece of paper that's stuck on my screen, if I tear the piece of paper off, underneath it, we are going to find w to the third power, because that's what x was covering up, right? That's what x was covering up here. So we take the x out, put the w to the third power back in. So we're going to have 4w to the third power minus 7. And then we're going to have w to the third power plus 7 as our second factor. And this would be the correct answer to type into Math Excel. All right, so let's take a look at this last page. It's kind of like what I did in the previous video. I have several examples here for you to try. So these are similar to problems that we've already done in this section. So give these problems a try. And so pause the video to do that, and then resume the video. And what I'm going to do this time is I'm just going to put the answers on the screen. So instead of going through all the works, I'm not going to have enough room, and this video is already getting kind of long. And so when you resume the video, you'll see what the answers are and check to see if you got them right. If you didn't get them right and you can't figure out where you went wrong, send me an email. If I'm your teacher, go ahead and send me an email, and I'd be happy to help you with whatever problems you weren't able to get. All right, so I paused my recording so that I could go ahead and work these problems out, and these were some pretty tough ones. First one wasn't too bad. So for the first problem, you should get 2s plus 5, s plus 1 as your two factors. The order of those two factors doesn't matter. So if the answer you got was s plus 1 times 2s plus 5, that's perfectly fine. It's the same thing. For the second one, you want to factor out the negative sign. At least I would really recommend it. You don't have to, but I always find when a is negative, things just don't go the way they usually do. So I factored out a negative sign. And then you get some pretty big numbers here. You get 35 times 12, which I don't remember what that actually is. I put my calculator away already. But you get a pretty big number from this. So I wanted to show you kind of the work I did. So I split up 35 as 7 times 5. and 12 is 4 times 3. And I regrouped them, and I got 28 and 15, which add up to 13, or they subtract, right? Negative 28 plus 15 will add up to give me negative 13. And so that's the direction you want to go. You want to split up negative 13s as negative 28s plus 15s. Do the whole factor by grouping thing, and this is what you should come up with. For this one, now this couldn't be a typo because I got this from the homework. You can see it's a snapshot. It's an image of the homework. It's not something I typed in myself. And this one threw me through a loop because I was sure expecting it to work out, but it actually doesn't factor. And actually I have a typo here. This should be c squared, if it'll let me write that. Okay, there we go. And so you factor out the common factor first, which will be 6. And by the way, I made a mistake, just to kind of be honest with you. I only factored out a 2 to begin with, and I didn't realize 3 could also be factored out. So you can factor out a 6, and that gets you down to this: 6c to the 4th power plus 5c squared minus 2. And when you go to try to factor that, and this is kind of a benefit of the AC method, right? A times c is going to be negative 12. B is going to be 5. And you should realize pretty quickly there's just no two numbers that will fit this description. There aren't two numbers that multiply to negative 12 and add to positive 5, right? There, you could try 6 and 2. That doesn't add up to 5, or subtract to give me 5. 4 and 3 aren't going to subtract to give me 5. 12 and 1 aren't going to work. So no pair of numbers that multiply to 12 will in any way get me a 5, whether I'm adding or subtracting. And so this can't be factored. So the best you can do is factor out the 6. Even though there's this, I was doing the whole substitution thing. I was putting w here for this, w squared here for this. All of that's for naught because this can't even be factored. The numbers just don't work out. So the best you can do is to factor out a 6. And this is what you would type into Math Excel. I apologize for that. So if you spent some time on it and got frustrated with it, I apologize. But just be on the lookout for that because there's going to be a problem like this on the homework. And then this one, you get a really gigantic number. So 49 times 36, even though there's two variables here, we can just use the AC method like normal. The AC method handles it just fine. It puts the variables exactly where they need to go. And so I just jumped right into 49 times 36, which is 1764, and B is negative 84. So I need two numbers that multiply to 1764 and add to negative 84. That's a pretty tough thing to figure out with such a big number. So I went back to where the numbers were smaller, split them up, and the only way, well, at least 49, the only way you can split that up is 7 times 7. I tried 6 times 6 with 36, regroup those in the only way that you can, which is to get 42 and 42, which do happen to add up to negative 84. So you want negative 42 and negative 42. You split this middle term up using that, and you do factor by grouping from there, and you should end up with 7q minus 6t times 7q minus 6t. You get the same factor twice, which is a little bit of foreshadowing of what we're about to be studying in the next section in 4.6. So that concludes the video on section 4.5, factoring expressions of the form ax squared plus bx plus c.